Hi, my name's Eric, and I started making since I was in middle school. In fact, I loved it so much that I posted videos of my projects online to share with the world. And although I wince at the thought of them now, they laid an important foundation for me for all aspects of mechatronics. As I moved into high school, I also entered FIRST Robotics. As there's only really me and one other person on my team on hardware, I had the opportunity to explore different complex mechanisms. For example, drivetrains, linear slides, intakes, claws and end effectors, and one launcher so far. For example, this intake and storage component that I worked on had over 2,000 runs of data and 12 prototypes. However, FIRST isn't just about robotics. I lead this initiative within my team. It's called STEM Without Borders. And of the many STEM kits that we have, like one example I designed is this planetary gear kit here. But what's special about this project to me is not the complexity of these designs that I've made, but rather how gratifying it is to see them in hundreds of kids around the world in diverse backgrounds, all sharing a same common interest in engineering and STEM. These are the types of things that keep me going and making projects outside of FIRST. For example, this 2 degree of freedom and 3 degree of freedom inverse kinematic simulator for end effectors that I made for beginner robotic enthusiasts. Another project I made is a novel computer vision algorithm for localization I developed with optical flow in OpenCV. This tracks relative movements using a singular camera and pinpoints the important locations on the screen in order to triangulate where you are. I also made Fusion 360's wire generator add-on, which gained over 1,500 active users within 6 months. It uses vector mathematics in order to generate various possible splines of a wire under the user's parameters. And to increase my productivity, I have created 3 Chrome extensions, like this one, where I utilize mindfulness and reflection to deter myself from unwanted sights. Through the grants and generous support of my friends, I had the chance to conduct research independently, where I designed, built, and programmed an infrastructure inspection robot over the course of 2 months. This is the first quadruped capable of delivering over 4 kilograms on any planar surface, which means it basically climbs walls, roofs, anything you can imagine, with over 50 kilograms of suction force. Using PID algorithms from the inverse kinematics to control leg movements, custom control loops and cued state machines, custom designed PCBs, that all culminated in the IEEE research paper with a research conference presentation that I attended in Japan. A recent project I did was with my physics group where we developed a ping pong ball launcher simulating a garbage disposal robot. This uses physics concepts that we learned in class like drag and moment of inertia to shoot the balls into the bins regardless of where the bins are placed through the detection of the red and blue squares in computer vision. Thank you so much for listening, and I'm really glad to have shared my passion with you. Have a good day.